All right, this is lesson 1-6, solving for day 1, compound inequalities. And then in our next video for day 2, we'll be solving absolute value inequalities. But today we're just going to look at some compound. So the word conjunction, a compound statement that uses the word con, so meaning kind of together, is true if and only if both inequalities are true. So both inequalities are true. So we've got this word and that kind of connects these two compound inequalities. And you can kind of see their graphs are connected. So this intersection is the and part of the graph. So conjunctions can be written as a single statement too. So for example, if we had this right here, this whole thing written together, it's basically saying this inequality and this inequality are true. So you can kind of put it all together. So let's take a look at solving this. And you've got two methods. The first method is going to be solving it separately. So let's go ahead and take a look at what that looks like. That's kind of when I covered up this side. And I just go ahead and write 10 less than or equal to 3y minus 2. That's one of them. And then the second one is if I cover up this side. Then I have 3y minus 2 less than 19. So now let's go ahead and solve those now that they're separate. We would add 2. This is just like what you've done before. And divide by 3. So 4 is less than or equal to y, or you could write it as y is greater than or equal to 4. And then we would solve the second one. Add 2. And divide by 3. So now that we have both of them, we could go ahead and graph it. And our little graph actually got put on the next page. So we'll just kind of draw one pretty quick here. So we have 4 and we have 7 and we have a closed circle at 4, but we have an open circle at 7. And then we are connected, since we're an and, we are connected in the middle. Or you could think of it as greater than 4, but less than 7. So greater than 4, but less than 7. So let's go ahead and take a look at how we would solve this if we had it all in one piece. So we didn't separate it. We did it together. And you can choose whichever method you like better, and you can use that to solve these. So what we're going to do is think about how can I get y alone? Well, the first step is going to be to add 2. Now when I add 2, I have to add 2 to both sides here. It's kind of like we're solving this side and we're solving that side at the same time. So now we have 3y less than 21 over here, greater than or equal to 12 here. So now what we're going to do is divide by 3 to final step to get y alone. So 4 less than or equal to y less than 7. So look, it's the same thing that we got here, and it's the same thing we got here. And then we've already got it graphed. So go ahead and try, if we turn to that next page, page 15, you're going to try example 2 on your own, whichever method you prefer. Go ahead and try that now and check when you're ready. All right, so go ahead and check your answer. Whatever method you used, you should have gotten x is greater than 7 and x is less than or equal to 15, and then graphed it here. So pause if you need to check some more. Otherwise, we're going to move on to the next section. So now that we've talked about the conjunction, we're going to talk about the disjunction. So this one is an or statement. So notice that our graph, we've got a line going this way and we've got a line going that way. So this is in a disjunction. It's true if and only if one or more of the inequalities is true. One or more of the inequalities is true. So notice how these having the word or makes the graph go kind of opposite directions here. So a union, the or part of the graph, kind of opposite directions there. So on this one, it's really already separated for us. So since that word or between them, they're already separated, let's go ahead and solve those. So first step, -3, x is less than -1. Over here, we're going to divide by -1, and what happens when we divide by a negative? Oh, we switch that sign. Don't forget to switch that sign. And we get +4 there. All right, so graphing this, we're going to have -1, and 0, 1, 2, 3, and 4. So we've got a closed circle here at 4, but we have an open circle here at -1. And we know that since we're an OR, we're going to be going greater than 4 and less than -1. So opposite directions. Go ahead and try number 2, pause, and then check when you're ready. All right, so go ahead and check number 2, both solving and the graphs, and see how you did. Pause if you need a little more time. And let's take a look at page 16, our last little section here for our day 1 video. We're going to do 1 and 2 together, and then I'm going to have you do 3 and 4 on your own. So we're going to go ahead and write these. Well, if it goes opposite, we know we're going to have the word or. And then we look to see x is at, it looks like negative, well, that would be halfway. This would have to be -10 if it's going by 2's. So this would be -9. So we know it's x, we know it's -9. Are we less than or greater than? We're a less than. So x, we want the tail end to go towards it. We do not want a line under here because it's an open circle. Next, we have x, and we're between 4 and 8, which would be 6. And we are going bigger, so greater than, with no line because it's an open circle. On the next one, we know it's an and. We don't need to put the word and because we're going to go ahead and connect them. So let's put our x. We know it's going to be less than something and greater than something. So now we just need our numbers. Well, 0, it's less than 0, and greater than -5. Let's double check our signs here with the open and closed circles. They're both closed. So that means we need to have lines underneath. So go ahead and try 3 and 4, pause, and then push play to check when you're ready. How'd you do? Go ahead and check. Double check those numbers, double check your inequalities, and then make sure to write any questions that you have down here so we can answer them in class.